What's up, math scholars? Glad you're joining us for part 2 of our study guide. Who's been practicing their unit circle at night?
Sam has.
Yay, Sam! We got like 2 people raise their hands. Maybe all 30 of you, well, there's like 28 of you, should go home tonight and practice unit circle, blank unit circle. So you can grab one for me, and if you're at home watching the video and you don't have one, print one off the internet. They're located everywhere. Just Google blank unit circle. Who's excited that it's snow today? Yeah! Snowstorm! Deep, 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 deep snow. That's a song from Frozen. You guys don't watch Frozen?
Yeah.
Elsa and Anna. Yeah. What do you mean that you don't know? Arendale's in deep, 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 deep snow. Oh, I have a 2-year-old girl. I listen to the soundtrack in my minivan. All right, let's start with arc length.
What?
Probably. All right, so we're ready to go on this number 6. It's where we left off yesterday. We're going to do the arc length formula and the area of a sector formula. They are provided to you. Now, I do have an asterisk. Your theta has to be in radians. So it's 100 degrees in radians right now. Right, so converting will be our first step. We're going to convert that 100 degrees to radians by doing a pi over 180. We did this yesterday. That's 100 pi over 180, and the zeros can cancel. What does 10 and 18 have in common that I could divide out? A 2. So 10 divided by 2 is 5. 18 divided by 2 is 9. So that's what we're going to be using as our theta in our formulas, not the 100. Gotcha? All right, so arc length, I have the formula up on the board right now. It's r times theta, where r is the radius, 10, and theta is the degree, or sorry, the measurement of the angle in radians. So 5 pi over 9. Let's go ahead and type that in. It's going to be a yucky decimal, but that's okay. Ten times 5 pi over 9. Did you get 17.45? Check me on that. And that would be in inches, because that's what our length measurement is. Thumbs up, you calculate out what I got. No one is nodding their head yes or no. So no feedback. It matched? Or we're still typing? I think they're still typing. Okay, perfect. Now we're doing sector area formula. 1/2 r squared theta. So 1/2 10 squared times 5 pi over 9. Not out of space over there. 1/2 times 10 squared times 5 pi over 9. I got 87.27. That would be inches squared, because that is an area. They're going to type it in and try it to verify I did that one okay. Pause the video while they try it. All right, a stepladder has an angle of elevation of 60 degrees with the front of a house. They do say they want us to draw this, so let's go ahead and kind of draw it. So I have like my house here. My house. Here's my ladder coming up. The angle of elevation would be 60. That's going to be right here. Angle of elevation is always like with the ground. Angle of elevation is always kind of up in the air up here. Or angle of depression would be up there. The length of the stepladder is 24 feet, so my 24 looks like it's my hypotenuse. Any other information they're providing that I'm forgetting about? Don't think so. At what height does the stepladder meet the house? So are we looking for this measurement down here along the ground or the measurement up here along the house? So my X will go right there. For one ticket, let me know whether we are using sine, cosine, tangent, or Pythagorean theorem. Jessica. Sine, I agree. Good. So we're going to use sine because this X is opposite the 60 and this 24 is a hypotenuse. And sine of theta is opposite over hypotenuse. All right, I'll give another ticket to somebody who can put all these numbers in the correct locations for me in my sine setup. Hannah. because the 60 is the angle, so it has to go in for theta. She's got her opposite and her hypotenuse. Okay. Make sure you're in degree mode before your quiz tomorrow if you haven't checked yet. But we're going to multiply both sides by a 24 and we'll have our answer. So 24 times sine 60. 9.78. And that would be in feet. That's a measurement. That's how high up it goes. Right. Alrighty, number 8. I love these. You just answer with a single letter. You don't actually give me any number answers. So let's look for where negative 90 would be located. Let's circle that location. Where's negative 90 located? And here at the bottom, because we would start at 0 degrees and go in a negative direction, which is clockwise, 90 degrees. Now, just a refresher, you have to have this memorized. Cosine is x, sine is y, and tangent is y over x. So if I'm looking for cosine at negative 90, I would want J or K? J, because cosine is the x value. Make sense? Does that make sense? All right, where would 135 be located? Keep in mind, this is 180 and this is 90. So 135 is probably at TU. Now, do I want T or U if I'm wanting sine? U, because it's a y value. Now, you might be wondering about tomorrow, the whole 7 pi over 6 thing. When you turn in your non-calculator portion of the quiz and you grab a calculator portion of the quiz, you'll also be grabbing a formula sheet. It looks like this little guy. It's got all the formulas that are on the board on it, just in case you sit far away and can't see it, but it has a filled-in unit circle in the back. So you could search for 7 pi over 6 that way and not actually have to convert it. So 7 pi over 6 is located at 210. So 210 would be about right here. VW. Would we want V or W if we're doing sine? W. Y value. And then do you know where 660 is? I don't, so I'm going to subtract a 360 from it. It's located at 300. 300 is probably at M and N. So M would be cosine. Very good. Oops. All right, for number 9, I would definitely just refer to my unit circle that I would have in front of me, this little dude, and I'd go to 330. So everybody have a unit circle in front of you that you could go to 330? You can get one out. 330. The coordinate at 330, if you lost your unit circle, is radical 3 over 2, comma negative 1/2. So keep in mind, cosine is x, sine is y, tangent is y over x. And then all of these are just reciprocals in the first 3. Now, one class was like, will I put these out of order tomorrow just to mess with you? I'm not going to do that to you. So sine and cosecant will be reciprocals, cosine and secant, and tangent and cotangent reciprocals. I'm not going to scramble the order. So let's start with sine. What's the y value at negative 3, or at positive 330? Negative 1/2. What's the x value at 330? Radical 3 over 2. All right, tangent, we might need to do a little bit of work. Tangent is y over x. So tangent is y over x. So we're going to need the y value on top and the x value on bottom. What do we do about reducing down fractions that look like this? Multiply by the reciprocal. So you keep that negative 1/2 like this, and you reciprocal your second fraction. Tangents are kind of awesome because things always cancel out. So it's negative 1 over radical 3. And I'm okay with you leaving it like that. You don't have to do any rationalizing for me. All right, for one ticket, I want somebody to tell me what sine or cosecant, secant, and cotangent look like. Connor.
Cosecant would be negative 2 over 1.
I'll just write negative 2.
So it's negative 2. And then 2 over radical 3. And then radical 3 over negative 1.
So I'll just go with negative radical 3. Yep. And as far as like this one here and this one here, I'm okay with you not rationalizing the denominator. If you scholarly people really want to do that, you can do it. Or you can just save your rationalizing for next year, because they'll definitely make you do it next year. Probably not math studies, but pre-calc. All right, I think we're on the last one, right? 10?
Yes, ma'am.
Sweet. You just need to remember that a reference angle is always the angle that your angle is making with the x-axis. So you gotta kind of keep in mind that 180 lives on the x-axis and 360 lives on the x-axis. So 320 would probably be about here, correct? How far is 320 from 360? That pink little line there is our reference angle. Yep. So that's called theta prime, if you want to remember what it's called. Theta prime is your reference angle. It would be 40 degrees in this case. All right, let me do a sketch on where negative 100 would live. Negative 100, I would spin this direction 100 degrees. No, that would be right. It'd be past 90, yeah. Sorry. Gotta turn my brain on this morning. This would be negative 90, so negative 100 would live somewhere over here. Now, honestly, I would probably just figure out what that positive angle is. That's going to be your easiest way to do this. So 100 plus 360 is what? 260. 260 is living exactly where we just were. But we can figure out how far 260 is from 180. 80 degrees. So my theta prime on part B is 80 degrees. And then my personal preference for 4 pi over 3 is just think about what angle equivalent that is. So I would look at my unit circle for 4 pi over 3. Did anybody find it? You'll have this little guy tomorrow. It's 240. So 240 is right here. 180 is right here. How big's the reference angle? (240) and 180, just subtract them. 60 degrees. Now, since the original problem was in radians, you'd probably want to convert yourself back to radians. So you can just look at 60 degrees on the unit circle and see right away it equals pi over 3. That's just the easiest way I've found to do these, is just think in degrees and convert yourself back at the end. So, well, let me pause this, answer some questions, and we'll wrap the video up. All right, well, that kind of wraps up the video today. So hopefully this kind of helped you with your studying. We're going to hit stop and then just do some study party problems with kids in class. Goodbye.